Alright, this is how you do Unit 5 practice problems for lesson 1. Using specific heat capacity and utilizing this formula. So at first, it's asking us how much energy was used, and energy, usually this one. So for the how much heat, how much energy, how much heat. These first three will be utilizing the original equation. So we start off with Q equals M, usually means mass. Delta T is usually TF minus TI. And C is usually the specific heat capacity. Alright. So for this would be Q equals the mass, which is 5 grams. The delta T is 80, it's just 80 minus 20, which is 60. And then the heat capacity, which is 0.092. And when you calculate that, that's just 5 times 60 times 0.092, equaling 27.6 calories. It would be Q equals mass, 20 grams, times that by temperature change, so 29 or 10 to 29, so TF would be 29, TI 10, because TI stands for T initial, TF stands for T final, so it would just be 19 times that by 0.1, calculate that, which equals 38 calories. For this one, it's, even though it uses the word cools, there's still TI and TF. So it'd be Q equals 30 grams times that by about 71. And then 1. So it'd be 30 times 71. Which equals 2,130 cal. But interesting enough, this actual reaction is endothermic. Okay. So for this one, it's asking specific heat capacity, which is C. And Q would always be on top. So this would be, I shall show up here. To get C by itself, you need to divide by M times delta T over here, which would get us C by itself. So for this, it would be Q over mass times delta T. So that'd just be C equals calories on top. And you'll notice actually for most variants, the Q's hours on top. So just remember calories on top. So 10 cal times the mass, which is 3.1 grams. And delta change, it only has one temperature, so we just use that. Which equals that, so then we just put in our calculator, 3.1 times 17.9, equaling about 0.18, and then I think, it'd be calorie per gram degrees Celsius. The temperature of sample of water increases from, mass. Okay, mass you just divide C times delta T, bring it over there. Like I said, calories are still on top. So another variant, calories on top. So for this, it'll just be mass equals Q over C times delta T. Therefore, M equals 5650 cal over 1 cal per gram degree Celsius over 26.6. We just put that in our calculator, 5650, and then just divide that by 26.6 because 1 doesn't amount to anything. And that should get us around 212 grams. Okay. Specific heat. Just remember C equals Q over mass times delta T. So therefore C equals C equals 47 over 10 times 25.4, which equals roughly about 0.185 calories per gram degree Celsius. All right, what is the final temp? Okay, this one's actually unique, I guess, because if it was just a normal something for T, it'd just be that. So it would be just 54 times, and like we did before, we only used one temperature, so you'd probably use 25, and then you times that by 4.5. And actually, if you put this in your calculator, 54 25 times 4.5. It definitely doesn't. It definitely doesn't give you the right answer. So it's actually far too small to be used. So we do use this formula, but just remember delta T is equal to TF minus TI, which looks familiar on a thing. So if you're looking for either or, you either subtract or add and bring it over here. Okay, so instead of having delta T there, we'll insert TF minus what is that final temperature? So we're looking for TF. Minus 25 is equal to the calories over mass, which is 4.5 times 0.0. Oh, I messed up a little in there. You get what I'm trying to do here, though. Because if you were to do it that way, instead of the 4.5 and just use 0.09, you would still be a little too small. So then we solve for this. First, 54 divided by 4.5 times 0.09, which equals approximately 133. Then to get TF by itself, we add 25, which results in 155 degrees Celsius for our final answer to get rid of that. Specific heat is C, so C equals 5 569 over 155 times 15, which equals 0.24 calories per gram degree Celsius. And lastly, what is the heat? Specific heat. So it looks like we're using C again. Don't forget C equals Q over M times T, or delta T. So C equals 12 over 2.5 times 5, because of the 5 difference here. Okay, so I just put in the calculator, so 12 and then 2.5 times 5, giving us an answer of 0.96 calories per gram degree Celsius. And that's how you do those practice problems.